Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is procedural programming module, and the today's topic is next chapter, that is chapter number 21, more Linux programming. That is how to do Linux programming in a more advanced manner, that is a more Linux programming. Till now we have discussed chapter number 20, that is a Linux programming. Now moves to the next topic, that is chapter number 21, that is more Linux programming. That is a advanced part of the Linux programming, or extended part of the Linux programming, that is a more Linux programming, right? So let's start the session. So this is chapter number 21, that is a more Linux programming. In this there are multiple topics, multiple scenarios. One is communication using signals, that is how to use the communication using the signals. Then handling multiple signals, that is how to handle multiple signals. Then registering a common handler, that is how to register a common handler. Then blocking a signals, that is how to block the signals. Then event driven programming, then where do you go from here, then summary, then exercise. So these are the few topics that is available in this chapter, that is a Linux programming, that is more Linux programming, right? So let's start with the first topic, that is how to communicate using the signal. First of all, there is a theory, that is your introduction part, that is how to perform the communication in the Linux programming. So this says communication is the essence of all the progress, that is every part needs the communication, so it is the essence of all the progress that is available. This is true in real life as well in programming. That is communication is very important in the real life for the personal usage as well as in programming. In today's world, a program that runs in isolation is of little use. That is, in the day-to-day scenario, a program that runs in isolation is of little use or no use. A worthwhile program has to communicate with the outside world in general and with the operating system in particular. That is, a program has to communicate with the outside world in the general and with the operating system in a particular way. Chapter number 16 and 17 that we have discussed, that is a window-based program, that is how to communicate, or how window-based program communicate with the windows. In this chapter, how we will explore, or we will see how communication is done using the Linux. That is how communication happens under the Linux. So the first topic is communication using the signals. That is how to do the communication using the signals. That is how to communicate with the help of a signals. In the last chapter we used fork and the exec library function. So we have discussed, or in the last chapter we have discussed the two functions, two library functions. One is the fork function and one is the executable library function, to create a child process and to execute a new program respectively. That is how to do the, or how to create a new process and how to execute a new program respectively, or how to execute a new program. We have discussed about the fork and the executable. So fork is used to create a child process and the executable is used to execute a program or execute a new program, so that the exe file will be created. These library functions got the job done by the communication with the Linux operating system. So these library functions is used to get the job done by the communication, to get the how we will communicate with the help of the Linux operating system. Therefore, the direction of communication was from the program to the operating system. The reverse communication, that is from the OS to the program, is achieved. That is, first of all, there is a communication from the Linux to the OS, that is the program to the OS. In the same way, there is a reverse communication, that is from the OS to the program, that is also achieved by using the signal. So communication is achieved by passing the operating system, or by passing from the operating system to the program is achieved using the mechanism that is known as a signal. Let us now write a simple program that would communicate, or that would help you to done or to experience the signal mechanism. That is how to do the signal, or how, what is the signal, how we can communicate with the help of a signal, right? So let's see the program. This is a program. First of all, there is a int main that start with the main function, that is a int main. Then there is a while one, that is a while is used, while looping is used, and there is a one, that means it will continue, it is a indefinite looping, that is a while one. Then there is a printf program running, so it is printed that is a program running. Then there is a return 0, that is at the end there is a return 0, right? Then this says the program is fairly straightforward. So this is a straightforward program. All that we have done here is we have used an infinite loop while loop to print the message program running. So we have used the infinite looping, that is the program running, to print the message, that is a program running on the screen. When the program is running, we can terminate it by pressing the Control C. So we can terminate the program, we can finish the program by pressing the key, that is a Control C. When we press Control C, the keyboard device driver informs the Linux kernel about the pressing of this special combination. That is, the device driver informs that is the Linux kernel. So it is the duty of the device driver to communicate with the Linux kernel, that is the pressing of the control key, that is a Control C. That is a shortcut key that is used. Since we have done nothing to handle this signal, the default signal handler gets called. In this default signal handler, there is a code to terminate the program. So this keyboard or the device driver has to communicate with the Linux kernel that a shortcut key is used, that is a Control C. Hence, on pressing the Control C, the program gets terminated. So this is the procedure how it will terminate. The kernel reacts to this by sending a signal to our program. So if we have done nothing to handle this handle, or nothing to handle this signal, the default signal handler gets called. So therefore, when we press the Control C, that means the program is terminated, or program gets terminated. But how on earth would the default signal handler get called? That is, how we are able to achieve the default signal handler, or how we can achieve this? Well, it is very simple. It is very simple to achieve the default signal handler. There are several signals that can be sent to a program. That is, there are multiple signals that is available that we send to a program. A unique number is associated with each signal. That is, a unique number is available with each signal. To avoid remembering these numbers, they have been defined as macro like sig int, sig kill, sig continue, etc. in the file signal.h. So these are defined, or these are the macro that is defined in the file that are defined in the header file, that is a signal.h. So how communication done, or how the default signal avoids or uses this one, that can be done, or that is defined in the macros. Like these are the macros that is available in the file, that is a signal.h. Every process contains several signal ID, that is, there are multiple signal IDs that is available, like function pointer that pairs indicating, or these are the function pointers that are indicating for which signal which function should be called. That is, for which signal which function will be used, which function will be called. Therefore, if we do not decide to handle a signal, then against that signal ID, the address of the default signal handler function is present. It is precisely this default signal handler for sig int that got called when we press the Control C. So when we press the Control C, the program is terminated, that is using the signal int, that is the sign int, when the above program was executed. Int is in sign int stand for the interrupt, that is the signal interrupt. That means interrupt the signal, that means avoid the signal, that is the interrupt signal. Let us now see how we can prevent the termination of our program even after hitting the Control C. That is, how we can prevent that our program will not terminate. That can be used, or that can be done by pressing the key or hit the key, that is the Control C. This is shown in the following program. So this is shown in the following program how Control C is used. There is a hash include signal.h, that is uses the signal, that is the signal.h. Then there is a void signal handler. Then int sig num, that is a sig num is used. Then this is the curly braces. Then printf sig int received inside sig handler. So this is mentioned over here. That is print the statement. What is the statement? That is the interrupt signal is received inside the signal handler. So this is the program and one of the header file that is used that contains all the functions, all the macros like sig int, sig kill, sig continue. So these are used. So this is the header file that is used. Then there is a void sig handler, then int sig num, then there is a printf, that is a sig int received inside sig handler. This is a printf statement. Now there is a int main, that is a main, that is a starting main, that is a int main. Then there is a signal sig int void sig handler. So there is a signal, then these are the various argument in this signal. That is a sig int, that is a sig interrupt, then there is a void pointer, then there is a sig handler. Then there is a while one, that is this is the looping that is used, that is a while one. Then there is a printf for printing purpose. What does it contain? That is a program running, that is a program is running, that it will print n number of times, that is a program running. Then there is a return 0, right? So this is the int main that is used as a function that is used for the main function that has some return time, that is a return 0. In this program we have registered a signal handler for the sig int signal by using the signal library function. This is the library function that is used, that is a sig int. The first parameter of this function specifies the ID of the signal, that specifies the ID. This is the ID of the signal that we wish to register. The second parameter is the address of a function that should get called whenever the signal is received by a program. This address has to be typecast to a void pointer before passing it to the signal function. So this is used as a void pointer because before it passes to the sig handler, right? So this control C is used for the register handler. So this is the address that is typecast with the void pointer before passing to the signal function. Now we press the key, that is a control C, the register handler, namely sig handler would get called. So this is the signal handler that is used for the void main, that is used for the handling the signal that is preceded by the pointer, that is the void pointer. So this is this function would display which function, that is a signal handler function, would display the message that is a sign int received inside signal handler and return the control back to the main function. That is, it passes the or it displays the message that is a signal int received inside the handler. So this is the message that is received, that is used with the help of the signal handler. I'm so sorry. Note that unlike the default handler, our handler does not terminate the execution of our program. That is, it does not terminate the execution of our program, that is a default handler. So the only way to terminate it is to kill the running process from a different terminal. That is to or the only way or the only method to terminate it or terminate the signal or terminate the program to kill its running process or kill the ongoing process from a different terminal. For this, first of all, we have to open a new instance of program, that is a terminal that is used. Then how to start a new instance, that is discussed in the appendix H, that is available at the end of the book. Now to do a PSA to obtain the list of processes that is running at all the command prompt that we have launched. So there is a PS that lists each and everything, that that is a command that is used to obtain the list of each and every processes that is running at all the command prompts that we have launched. Note down the process ID of a.out. So now note down the process ID of a.out that is available. Then finally kill a.out process by saying this kill 3267. Simply uses kill 3267 by simply uses the process ID, that is the a.out. In my case, the terminal on which I executed, that is the author says the terminal on which he executed, that is the a.out, was TTY1. So this is the terminal that is used, that is the terminal 1, that is a TTY1, and its process ID turned out to be 3276. In your case, the terminal name and the process ID might be a different number. So this depends on the program to program how they will be executed. There will be a different unique ID, different process ID, different employee ID, different terminal number, different terminal cases, and so on. If we wish, we can abort the execution of our program in the signal handler itself by using the exit 0 beyond the printf. So at any point of time, we can terminate the program at any time by using the exit 0. Note that signal works asynchronously. That it works asynchronously. That is, it works in an asynchronous way. How it will be executed, right? That is, when a signal is received, no matter what our program is doing, the signal handler would immediately get called. Once the execution of the signal handler is over, the execution of the program is resumed from the point where it is left off when the signal was received. So it is left off, or it is assumed from the point where it is the left off, or where it is left off when the signal was received. Now, next topic is how to handle multiple signals. So till now we have discussed how to handle the signals. Now it's a time to discuss how to handle multiple signals that is available in the program. That is, if there are more than one signal, so how we can achieve or how we can handle multiple signal at the same time. Note that we know how to handle one signal. Let us try to handle multiple signal. That is how to handle multiple signal. So let us now try. Here is the program to do this. That is how to handle the multiple signals. This is a hash include unistd.h, hash include systype.h, then hash include signal.h. So these are the three header files that is used. One is the unistd.h, then there is a systypes.h, then there is a signal.h. So these are the three header files that is available in this. Then this is the function that is used, that is the void int handler. So int handler is the name of the function and void is the return type. Then there is an argument that is a sig number, that is a signal number, that is a signal. Then printf sig int received, that is a interrupt signal, that is a signal interrupt received, that is using, or that is done by using the printf, that is a signal interrupt. Then there is a void term handler. So one is the int handler, then there is a term handler, then there is an argument that is a int sig num, that is a signal num is received. Then there is a printf that is used, then there is a sig term received, that is it will print as it is, that is a signal term received. Then there is a next function that is a count handler, then there is a int sum num, then there is a printf again, the sig count received. So this is the way how it print three messages with the help of different functions. One is the int handler, one is the term handler, one is the count handler. Then there is the int main, that is the starting of the main, that is the signal. So one is used, that is a signal, that sig int handler. So this is used as a argument, that there are two arguments, one is the signal interrupt and one is the int handler. Then there is a signal, then there is a sig term, that is a sig term is used, then there is a term handler, right? Then again there is a signal, then sig count, then there is a count handler. So these are the few arguments that is used in the signal. Then there is a while one. While one means it will execute in an indefinite loop, that is a while one. Then there is a printf, that is a program running, that is it is used as a program running, that is a print as it is, then there is a return 0. So whenever this function gets called, it will pass the control to this one, that is the int handler. And when there is a function, that is this one, that is a sig term handler, that is used over here. Then there is a count handler over here. So these are the various argument that is used for this signal, that is used for the int handler, that is used for the term handler, and that is used for the count handler, that is a continued handler. Then there is a while one, that means the execution or the indefinite loop. Then there is the printf, that is a program running. In this program, the above program, apart from sigint, we have additionally registered new signals. What are the new signals? That is the sig terms and the sig continue. That is the sig term and the sig continue. The signal function that is used is called twice or thrice. Why it is called thrice? One is for the signal interrupt, one is for the signal term, the termination, one is for the signal continue. That is a sig count. So there are three functions that is used. So the signal function is called tries to register a different handler for each of these signals. After registering the signals, we enter an indefinite while loop to print the program running message on the screen. So after registering on the signal, or after registering with the signal, an indefinite loop is used in this program, that is a while one, to print the message, that is a program running on the screen. So the next paragraph says, as in the previous program, we have used or we pressed Control C for the handler, or the handler for the inside int, that is the int handler is called. So whenever we press the Control C, so the int handler is called. However, when we try to kill the program from the second terminal, so this is the first terminal that is used. So whenever we need, or whenever I want to terminate the program using second terminal, using the kill command, the program does not terminate. Why? Because when the kill command is used, it sends the running program a sig term signal. So whenever we use the kill command, it will not get terminated. What is the main reason why it is not terminated? The main reason is that it is the kill command is used, it sends the running program into a sig term signal. So whenever it is using this kill command, it is directly passing to the sig term signal. The default handler for the message terminate the program. Since we have handled this signal ourselves, the handle for the sig term, that is the term handler, gets called. So there are various functions like sig terms and sig continue, sig int are the macros, and the int handler, term handler, continue handler are the functions. So as a result, the print statement in the term handler function should get execute, and the message, that is the sig term received, get display on the screen. Once the execution of this one is over, then comes to the next part, or then resume the execution and continue to print the program running. This is because we are supposed to terminate the program. Suppose use the following command from the other terminals. That is again coming from the other terminal, other signal. What is the command? That is the signal, or kill signal, kill 3276. That is kill the signal. That is the unique number is 3276. As the command indicates, we are trying to send a signal. We are trying to send a sig kill signal to our program. A sig kill signal terminates the above program. That is a sig kill signal. More signals may be caught by the process. That is, the more signal may be caught, may be used by the process. But there are a few signals that the process cannot catch, and they cause the process to terminate. There are few signals that is available that cannot be caught by the programs very easily, and they are uncatchable signals that cannot be cached. The sig kill signal is an uncatchable signal that forcibly terminates the execution of a process. So the sig kill signal is used, that is used to forcefully that is used for the forcefully terminate the execution of the program or the process. Note that even if a process attempt to handle the sig kill signal by registering a handler for it, still the control will always land in default sig kill handler, which would continue the program. This is saying we can kill the, or we can handle the sig kill command, or we can handle by registering it with the handler for which they are using, that is done by the SIG-kill handler. Then the next part says the SIG-kill signal is to be used as a last resort to terminate a program that gets out of control. So the SIG-kill signal is used, or the SIG-kill, that is a keyword, that is a macro that is used as a last resort. Last resort means the last part to terminate the program that gets out of control. This means it is a termination, that means killing the program. One such process that makes uses of this signal is a system shutdown process. So one of the process that is used or that make uses of this signal is a system shutdown process. It first sends the SIG-term signal to all the processes. So whenever we use the kill signal for killing the command, we first of all we have used the signal, that is the SIG-term signal, to all the processes. Then waits for a while, thus giving a command to all the running processes. That is then first of all it sends a SIG-term signal that is used to each and every process. Then give a grace period to that running program. However, after the grace period, it forcibly terminate the running processes using the SIG-kill signal. So first of all, it gives a time that is done, or that is used by using the SIG-term signal, that is done by using the SIG-term signal to all the processes. That is the first of all it uses, or first of all the signal is used, that is a SIG-term signal. Then at last it is terminated by using the SIG-kill signal. That leaves only one question: when does a process receive the SIG count signal? That is, what is the criteria, what is the scenario in which we are using the SIG-kill signal? A process under Linux can be suspended using Control Z command. So whenever we use the Windows, that is whenever we press the Control Z command, that means undo. So that a process under the Linux, that is a Windows command, that is a Control Z, is used for the undo. But whenever we use the Linux, whenever we use the process under Linux, it is used for the suspended purpose. That is, the Control Z is used for the suspended purpose. This process is stopped because it is not terminated. So it is stopped like this one because it is not terminated, and Control Z is available. That is, it is suspended. That is, it is not terminated even if it is suspended. This gives rise to the uncatchable SIG stop signal. That is, from this it is going to rise the new concept, that is a SIG stop signal. To resume the execution of the suspended process, we can make use of the FG command. So to resume the execution, we have used the command, we have used the new command, that is the FG command, that is a foreground command. As a result of which the suspended program resumes its execution and receives the SIG count signal, that is a signal continue. That count means the continue execution. So this is the meaning of the count, that is the continuing the execution. Now next topic is registering a common handler, that is how to register a common handler. This I am going to start in the next class, that is tomorrow's class, but today I am going to continue with the practical part that we have left with the functions. Yeah, so let's start the practical part first of all, then move to the next topic. What is the next topic for you? That is how to register a common handler. That is, there are various handlers that is available, and to how to register a common handler that is available under the Windows. So let's start the practical approach right now. So let's do the practical approach. In the last class we have discussed about the functions, global variable, local variables. Now I'm going to continue with the same steps, same procedures. Now I'm going to start with the new topic, that is call by value and call by reference. That is how to passes the address or how to pass the value. That is whenever we pass the value, that step is known as, or that procedure is known as call by value, and whenever we use the addresses, then the procedure is known as call by reference. So the first part is call by value. First of all, includes the same header file, that is the hash include stdi.h and the conio.h. Then there is a void main. Then there is a curly braces over here. Then there are multiple variable that is declared, that is xy, change. So these are the three variables, and there are two arguments in this. One is the int, another is also int. Now clear the screen, that is clr scr. Right, then uses the printf for printing purpose. Then simply gets the value from the user, that is enter values of x and y. Then uses the scanf for scanning purpose, that is the scanf. Uses the percentage d over here, because there are two values, we have to change the values, so we have used percentage d and the percentage d. Then x, that is the ampersand x, ampersand y. Then uses the function, that is a change x comma y. Right, this is the function calling. Then again uses the printf statement, that is after or in main, that is in main function, what is the value of the x and y, that is x equals to percentage d and y equals to percentage d. Then uses a double quotes over here, then uses two variable, that is x and y. Then return 0, because we have used no, there is no requirement of the return 0. Now there is a get ch for printing the output. Now this will be closed over here. Now uses the change function, that is the definition of the change function. Two variables are declared, that is the int a, int b. That is two variables are declared over here. Then uses the curly braces over here for definition of the function. One variable is declared, the name of the variable is k. Then swap the function, that is interchanging the values of the function. K equals to a equals to b equals to k. So k is like a temp variable, temporary variable. Now uses the printf, that is in change function. X and y. Right, and we have used the slash n over here for printing in the next line. Then close this one by using the closing braces. Now if I execute this code, compile this code, there are two errors, undefined symbol x and y. So in this we have to use the AB, because this is not xy, this is a comma B. Now there is a warning, that is function should return a value, that is it must return a value, that is we have to use the int main and the this one. Now enter the value of x and y. Suppose we have entered 10 and 20. In change there is a 20 and the 10, and in main there is the same value, that is a 10 and the 20. So this shows when we use the change function, the values are changed, that is x becomes 20 and the y becomes 10, but in main function it is the same, that is the 10 and the 20, that is it cannot be swapped. Now let's see what is the criteria, how it will be used. So this is the main function that is used. There are two header files that is used. One is the stdio.h, one is the conio.h. Then there is a void main, that is the starting of the main. Then there are two variables that is declared, that is the x and the y, and there is one function that is used, that is the name of the function is change. So the function name is change, and there are two arguments in this. There are two data type in this defined, that is int int, that is it can accept two values that is of integer type, that is int and int. Then there is a clear screen, that is a CLR, SCR. Then uses a printf, that is used a printf, that is enter the values of x and y, that is enter the values of x and y. Then there is a scanf for scanning purpose, that is the scanning the values that is entered by the user, that is ampersand x and the ampersand y. Then call the function, that is a change xy. It means calling the function, that is a xy, and the calling the function name is change, and the argument that is used in this x and y. Now printf, that is in main what is the value of x, in main what is the value of y. So it is saying in main x equals to %d, y equals to %d, and the two values are printed, that is the x and the y, right? So whenever a cursor moves to this part, that is a change xy, it directly jumps the cursor to this place, that is a change int a int b. So whenever there is a function that is used, that is change xy, it directly moves to this one, that is a change int a int b. Now uses this one, that is go to this one. In this we have defined one variable, because we have given the data type over here, but we have not given the variables. So these are the variable that is declared, that is a and the b. So there are two variables that is declared, that is int a comma int b. Then there is a third variable that is declared in this, that is used for the swapping purpose, because the program is how to swap the values and what is the difference when we swap the values. So a new variable is declared, that is a k. Then uses the variable, that is k equals to a, that is assigns the value of a to the k, that is the x value that becomes a, that is the name of the x is changed in the function definition, that is the a. So k equals to a, that is the a value is defined, is stored in the k. Then a equals to b, then the b value, now a becomes empty. Why? Because the a value is stored in the k. Now that store the value of b to the a, because a is empty, so now store the value of b to the a. Then store the value of k to the b, because the b is now empty, so store the value of k to the b. So finally a got the b value and b got the a value. So the values are interchanged, so it is printed like this one. In change there is a value, that is the a and the b. Now listen carefully, this is the important point. Whenever it print a and b value, it vanishes with this curly braces. Why? Because we have passed the value, we have not passed the function address, we have passed the value, that is the x, y. These are the values, not the addresses. So whenever we pass the value is limited to the block only, its scope is limited to the one block only, that is it is limited to only this block. Whenever its block is finished, the values are vanished, that is the values are remain the same but the values is in the void main. This is the concept that is known as call by value. That means whenever we pass the values in the function definition, or the values or the actual argument that we are passed on the formal argument, and whenever we make the changes in the formal argument, what are the actual argument? This is the actual argument, this is the formal argument. Whatever the changes that we made in the formal argument, that is this one, does not impact on the actual argument. In this is remain same, that is a, for example 10 20, but this change, that is 20 and 10. So this is called by a value. I'm repeating again, whenever we pass the value with the function, that is known as the call by value. In this the actual parameter and the formal parameters are different, and if we made any change in the formal parameters, that in the function definition, if there is any change that does not impact on the actual argument, that does not impact on the main function, because the formal argument are thus the photocopy of the actual argument. It is just a photocopy, that is xy ab. So ab are the just the photocopy of the xy, not the functions. So this is the concept of the call by value. So if I execute one more time, and if I give the values as 10 and 20, in change there is the change in the value, that is x becomes 20, y becomes 10, but in main that remains same. Why? Because the change value is limited to the function definition, because they are the formal argument, but in main it remains same, that is the 10 and the 20. So this is the program that is thus called by value program. Now if I change this program by using the ampersand, that is by passing the addresses. Now let's see how to pass the address. Simply uses the pointer over here, because we have passed the address, simply uses the pointer, that is the int pointer, right? Everything else remains the same. Now this is the important part. Instead of passing the values, we have passed right now addresses. This is the address, then this is save as, that is C, bin, and then name of the file is so this is the in this we have used this one. Now here we have to define the so here we have to define this function, we have to define this program by using the pointer A and by using the pointer B. So two concepts are used, that is the asterisk, that is the int pointer A and the int pointer B. Again in this we have to use the pointer, that is a pointer K, then pointer A, pointer K, now if I compile this code and if I execute this code, now if I pass the value as the same, that is the 10 and the 20, in change it is x equals to minus 12, so that means that is some mistake over here. Yeah, we have not used pointer over here, this is the mistake. If I use this one, now if I compile this code, enter the value of x and y, that is x and, yeah, whatever the changes, that is whenever we pass the addresses, if there is any change in the formal argument, that impact on the actual argument as well. Why? Because we are using the photo, or we are using the pointers, we are using the addresses. So if there is any change in the address, that is limited to that block only, or that is limited to that address only. That is the main function, or that is the address function, or that is the call by reference function. So whenever we use the call by reference, any change made in the formal argument is directly impacted on the actual argument. That remains the fix. So if there is any change, that remains the fix, that is also available in the main function. This is used. There is a scanf, that is the %x %y. Then there is a change, that is the %x %y, that is the x and the y. Then printf in main. These are the functions. So whenever the cursor moves to this one, this directly jump to this one. There is two more variables are declared, that is the pointer a and the pointer b. One more variable is declared, that is the third one, that is the pointer k. Then store the value address of a into the k, b into the a, and the k into the b. Then printf, that is the pointer a and the pointer b, that is storing the value of pointer a and b. And now whenever the cursor moves again to this one, the values remain same. Why? Because this is pointer, this is pointer, the value is same, that is the 20 and the 10, and in this again the value is same, that is the 20 and the 10. So it means whenever we pass the value, any change made in the formal argument does not impact on the actual argument. And the second one is call by reference, that is whenever we pass the addresses, then any change made in the formal argument is directly impacted on the actual argument. This is the case how it will be done. Right. So let's stop over here only. Let's stop over here only. In the next class, that is in the next class, I will be starting your next concept, that is registering a common handler. And again I am repeating, this is your recorded lectures. So please take your doubts along with you, and I'm surely clear all your doubts whenever I come to the class on the Monday. Today is Thursday, and Monday I definitely come to the class, so I clear each and every individual doubts, each and every doubt of the student. So let's stop over here only. Collect the doubt and mail to me, either mail to you, so that you cannot forget the doubts. So that's all today's session. Thank you so much everyone. Bye bye.